2019, paper 1. Alright, number 1 can be simplified as, well, I gonna fight up with this, right? I just gonna plug this straight in my calculator. Some of other calculators will be able to give out the answer in surd form. Mine is not going to. So what I gonna do, root 8 equals plus root 32 equals, take away root 162 minus 4.2426. I'm gonna check each answer and see if that is minus 4.2426. Minus 2 root 2 minus 2 point, nope, minus 3 root 2 minus 0.2426 minus 3 root 2. Alright, minus 4 root 2 could be a larger numerical number. And minus 6 root 2 could be even larger as well, right? But we can just entertain it and see what's the next two answers. Instead of minus 3, let's put minus 4 root 2. Minus 6 root 2 could be bigger. It could be smaller, but it could be bigger. For less than what I see. If a remainder of 3 is divided by, is obtained when this is divided by x minus 1, then k equals, so when I'm dividing by x minus 1, that will be f of 1. So I'm going to get 8 plus 4 plus k will give me a remainder of 3. 12 going across, k is equal to 3, take away 12, which is going to be minus 9. The inverse of if p then q is if q then p. Right? One thing I have here, I have a nice little table that I want to put for all of our questions like this. Alright, so the inverse of the inverse of if p then q is if not p then not q. 4 root x plus 4 into root 3x divided by 48 is equal to, alright, just like I did with the trigs in the last year paper 2018, I'm going to do the same thing with this. I'm going to pick a value of x, a very weird obscure value of x, and I'm going to calculate what this is for that particular value of x. So let me pick a brand new value of x now. Let me say x is equal to 0.123456, and I'm storing that in a. So 4 root a plus 4 root 3a, and I'm gonna put 4 root 3a in brackets divided by root 48. Hopefully my calculator, nah. Yeah, the calculator should divide it first, right? 1.7568. 153. What is 5 root a? Okay, cool. That's easy. Alright, so if we were to do the mathematics behind it, it could be something like this. 4 root x plus 4 root 3 by root x divided by 48, looking like root 16 by root 3. Yeah, the root 3 cancels with the root 3. This is 4, so 4 will cancel with the 4. 4 root x plus root x is 5 root x. Which of the following are factors of this? X to the power 4. Now, unfortunately, my calculator do have, you know what to call it, polynomials to degree 4. So what we're gonna do, just plug in x is equal to 1. Well, for the first one, we're gonna be plugging in x is minus 1, then x is 1, then x is 2. Minus 2. So I just gonna plug in x is equal to 1, which will tell me if 2 is a factor or not. So f of 1, I don't have to plug in nothing, it will just be 4 plus 8, take away 2 take away 6 take away 4 is equal to 0. So 2 is indeed a factor. So is either this or this. So let me just check. All of these have 1 in them, right? So me, I'm gonna bother to check and see what 1 is. I'm going to check and see if 3 is a factor or not. If 3 is a factor, then it could be, ooh, I go how to check 1, you know. I go how to check all. Oh Lord Father, I had to check all. Alright, no see. So far 2, you good. So 2 is good. Let me check minus 1, when x is minus 1. For the odd powers, I'm going to get negative. For the even powers, I'm going to get positive. So this is an even power, so it could be 4 by 1. Minus 8. 2 by minus 1 squared is 2, so it will be minus 2. 6 by minus 1 will be minus 6, so I will get plus 6 there, and then minus 4 in the end. Again, minus 4. So 1 is out of the question. 2 in the question, 1 is out of the question. So them not working, so the answer have to be C. Without even checking the third one, the answer have to be C. So you worked, you didn't work. Alright, so the contrapositive of the statement, if Jomo is a minor, then he is rich. Look, we have contrapositive right here. If Jomo is a minor, that's going to be Q, then he is rich. So Q, then P. The contrapositive is not Q, then not P. So not Q is going to be if he is not rich. But we're talking about Jomo here. So if Jomo is not rich, then he is not a minor. So this can work. If Jomo is not rich, then he is not a minor. Part C. Given that f of x is equal to that, the range of positive values of x for which f of x is 1 to 1. Alright, this is a nice question. And to see this question properly, I want to show all you the graph. Now, for those of you all who were my students from the get-go, this is a no-brainer for all you. All you're supposed to know what's going on here. For the other students, pay attention. 3x squared minus 6x plus 1. 3x squared minus 6x plus 1. This function is not 1 to 1. This is a many to 1 function. But if I restrict the domain, I'm going to draw back the function. 3x squared minus 6x plus 1. And I'm going to say x is greater than 1. I'm going to put it again. 3x squared. I wonder if I put f of x when x is less than 0. So f of x when x is less than 1. Good. Get that here too. Lovely. Now this is my function. The whole function and the domain is all the real numbers. And then this is just half of the function. This right now, as I have it, is 1 to 1. This, as I have it here, is also 1 to 1, which is half of the function. In order to know the domain for these two, all I either need the axis of symmetry or I need the x-coordinate of the minimum point. To cater for all types of questions, we're going to calculate the x-coordinate of the minimum point. So I'm going to differentiate to get 6x minus 6, put it equal to 0. And x is equal to, move the 6 across, divide by 6. I get x is equal to 1. That's the x value for my minimum point. On either side of x, my function is going to be 1 to 1. But the question says the range of positive values of x. So when x is greater than 1, my function is 1 to 1. If alpha and beta represents the roots of the equation, then the value of alpha squared plus beta squared is, well, alpha squared plus beta squared, this is going to be alpha plus beta all squared minus 2 alpha beta. From here, alpha plus beta is minus b over a, which is going to be minus p over 1, which is going to be p. So I'm going to get p squared take away. Alpha beta is going to be q over a. So p squared minus 2q is going to be my value of alpha squared plus beta squared. This is going to be a very common repeat question, right? When this is divided by x minus t, if we divide it by x minus t, we calculate an f of t to the power 4, because I'm going to get t by t cubed, t squared by t squared, t cubed by t, and t to the power 4, and I'm going to get 4t to the power 4. This is a common repeat question. Log 4 to base a plus log x to base a minus log 7 to base a is 2. Let me use laws of logs. We're going to get log 4x over 7 to base a is equal to 2. A squared is equal to 4x over 7. And we want to get x. 7a squared over 4 is equal to x. 7 over 4 a squared is equal to x. If log 16 to base a is 5, log a to base 2. Okay, so let me change this to here we're gonna do. Let me bring this to exponential. I'll get a to the power 5 is equal to 16. Then take log to base 2 on both sides. Log a to the power 5 to base 2 is log 16 to base 2. 5 log a to base 2 is equal to log 16 to base 2, that is 2 to the power 4, which is going to give me 4. And log a, log a to base 2 is going to be 4/5. That is the domain of the function. What is its range? Aha. Nice function, right? Let me plug in each of these points into the function, right? When we have minus 1 inside of here, we're going to get minus 1, which is minus 2. Then we're going to get 1 minus 1. Sorry, 0 minus 1, which is minus 1. Then 1 minus 1, which is 0. So this looking like the proper domain range for this particular function, right? But one thing we have to take into consideration is if there's a turning point within this particular domain. So let me just check and see something. Let me check when I differentiate, f dash x is going to be 3x squared. So we say let that be equal to 0. And I'm going to get x is equal to 0. So when x is equal to 0, that is where the point turns. And when x is 0, y is 0, so 0, 0 is the turning point, and it's going to be an inflection point. So D will be my answer. Aha! Look at the repeat question here. Alright, so just to show you all the repeat question, let's go back into 2018 and see if it's 2x minus a is greater than x. Um... 2x minus a is greater than x. Just remember, don't worry with the sign and the word in between them. It's always going to be less than a over 3 and more than a as long as the numbers persist. Less than a over 3, more than a. So the answer for number 13 is a. Which of the following graphs represents modulus 3 over x? I know part C is definitely a quadratic, part D is not a modulus, part B is not a modulus, so it has to be part A. Alright, modulus graphs only exist above the x-axis. Alright, C, yes, it exists above the x-axis, but it is very much resembles a quadratic. given that alpha, 2 alpha, and 3 alpha are the roots of the equation, the value of the constant k is, so if alpha is the roots, if these are the roots of the equation, then x minus alpha is a factor, x minus 2 alpha is also a factor, and x minus 3 alpha is another factor. When I multiply out all the factors, I'm going to get the cubic, right? Alpha is a constant, so a constant here by a constant here by a constant here will give me the constant. So when I multiply all three constants, I'm going to get minus 6 alpha cubed will be equal to 48. I'll get alpha cubed is equal to minus 8, and alpha is equal to minus 2. Now using the roots, alpha, beta, gamma roots, I'll know that how minus b over a is equal to 1, b is equal to k. Minus b over a is equal to the sum of the roots. So minus b on a in this case here, so the sum of the roots is equal to minus b over a, which is equal to minus k over 1. So minus k is the sum of the roots. So minus k is equal to alpha into 2 alpha into 3 alpha. So minus k is equal to minus 6 alpha cubed. If alpha is minus 2, minus k is minus 6 into minus 2. Well, we know what minus 6 alpha cubed is. That is 48. 3 2s are 6. 6. Oh, sum of the roots. Sorry. Minus 6 alpha is the sum of the roots, right? Plus alpha plus 2 alpha plus 3 alpha. So 6 alpha is equal to k. Alpha is minus 2. Minus 6 into minus 2 is k. Minus k is equal to 12. So k will be minus 12. So this was a little heavier thinking question in this particular year. Alright, when I add them, I will get positive 6, not negative 6. So 6 multiplied by negative 2 is minus 12. So k will be positive 12. Next, given that a is that and b is that, then the magnitude of 3a plus 2b. So 3a go be minus 9, 21. And 2b is going to be 4 minus 2. So when I add them, I'll get minus 5 and I'll go get 19. Minus 5 squared is 25. Plus 19 squared, 386. The answer is B. Alright, so again we have a compound angle formula that we could use here. Pi on 2 minus p cos pi on 2 cos p plus sine pi on 2 sine p. Cosine of 90 is 0. Sine of 90 is 1. So I'm going to get sine p. Repeat question. Let's take a look. 2 cos squared plus 3 cos minus 2. 2 cos squared plus 3 cos minus 2 is 0. And they want the value between 0 and pi that satisfies this. Right? And the answer was pi on 3. So once we get accustomed with what the repeats are, we will just write down what the answer is. Alright. Alright, similar story to what we had in the last paper. From here, x minus 2 all over 3 is equal to t. Let me plug that into here. Minus 6. Y is equal to x squared minus 4x plus 4 all over 3 plus x minus 2 all over 3 minus, no, over 9, sorry, minus 6, multiply everything by 9. 9y is equal to x squared minus 4x plus 4. When I multiply this by 9, the 3 and the 9 go cancel. So I'll get 3x, and 3 2s are 6. And 9 by 6 is 56. So 9y will be x squared minus 4 plus 3 is minus x. So we have a x squared minus x. So looking like we're gauging up to for A to be the answer. 2, 4, right? 3. Yeah. 4 minus 6 is going to give me 3 2s are 6. 54. I multiply wrong. 54. So 4 minus 6 is minus 2. Minus 54 minus 2 is minus 56. Good. So the answer is A. Alright, so I multiply wrong. You see, when you can't be too sure, just do it on a calculator now. Alright. Well, me, I'm going to fight up with this question. I just going to plug it in my calculator and see what we get, right? Change the calculator in degrees. Cosine 75. Sine 15. Minus sine 75. Cosine 15. Minus. Well, the only one that have a minus is B. Easy. Well, all I know this scene, right? We're going to check and see what root 3 on 2 is as a decimal. Minus root 3 on 2, a half and 1 and so on. The set of values of k for which the straight line intersects the curve with equation at 2 distinct points is, right, plug in alright, let me solve them simultaneously, right? So we will get substitute y into the second equation. Kx minus 4 is equal to x squared minus 2x. X squared minus 2x minus kx plus 4 is equal to 0. X squared plus minus 2 minus kx plus 4 is equal to 0. Two distinct points, b squared minus 4ac will be greater than 0. So b squared minus 4ac is going to be greater than 0. Expanding out, square the first sum, I get 4. Multiply the 2 inside and square it. So when I multiply, I get 2k, and I square it, I get 4k. Plus k squared minus 16. We're looking at greater than 0. Right, but I need to put it equal to 0 to calculate the critical values. I'll get k squared plus 4k. 4 take away 16 is minus 12 is equal to 0. I'm gonna be, hero. Solve this on my calculator. 1, 4, and minus 12. My two values are 2 and minus 6. We wanted greater than 0. So greater than is this. It's a positive x squared. Y point x supposed to be k and k. Minus 6 and 2. So x is less than minus 6. Union x is greater than 2. The answer is C. Repeat question. Let's check and see. Y squared is equal to x plus 7 and xy is equal to 6. Minus 2, minus 1, and 3 are my answers. Alright. So for this one, I could use the concept of plugging in a value for theta, but you see how we have plenty squares and bracket by bracket. We could, it's possible, if you're comfortable with your calculators, you could go ahead and do it. But I'm seeing some things that I can use here to my advantage. 2 sine squared theta plus cos squared theta, which is going to be 2 into 1. So this first thing here is 2. Sec squared minus tan squared, that is sec squared is 1 over cos squared minus sine squared on cos squared. So we get 1 minus sine squared all over cos squared. 1 minus sine squared is cos squared. So there's cos squared over cos squared. So there's 1. So 2 by 1 is going to give me 2. Okay. So in number 24, I'm going to take the answers and see which one of the answers reproduces the question. So I want to see, when I rearrange each one of these, which one gives me x minus 3 all over 4. If you're comfortable with other parametric equations in trigonometric form, are supposed to know what I'm talking about. So for the first one, I'm going to get x plus 3. That I give him, I need a x minus 3. Over here again, x minus 4. Over here, I'm getting x minus 3. And I want to make sure I get a y plus 4 when I rearrange the next one. I am getting the y plus 4 here. So one time my answer is going to be C. This was another repeat. I can't remember if it was minus 1 on root 2 or if it was 1 on root 2. Let me check back and see. Where was that question? Would not have been long, it would have been a little bit before. No. Where was that question? Was it further down? I guess it was. Not supposed to be further down. Oh, look at here. Number 26. It was minus 1 over root 2. Right, cosine of the angle between those two vectors, minus 6j and I plus j. Are we looking at minus 6j and I plus j? It's minus 1 on root 2. So the answer is indeed A. The minimum and the maximum values of these two functions are, this is a repeat, it is going to be 1/3. A circle has center minus 1, minus 1. The equation of the tangent to the circle at 0, minus 3. This is another repeat. I believe the gradient of the normal. Let me play no hero now, boy. We will get accustomed with what the repeats are, right? Right, so the gradient of the tangent was a half. Sorry, the gradient of the radius was minus 2, so the gradient of the tangent will be plus 1/2. So we're looking at a half x to be the answer. Just make sure that asking for the equation of the tangent, the equation of the tangent. So we're looking for plus a half, which is B. Ooh. The distance of an arm shaping machine from its starting position can be modeled by the equation D is equal to the maximum distance in meters. So the concept of R cosine x plus alpha and so on is to combine cosine and sine to be 1. The amplitude is going to be R. And we know that our R is always going to be the first coefficient squared plus the second coefficient squared, the square root of that. So this is a Pythagorean triplet, so that's going to be 13 to be my answer. A vector equation for the line through the points is, alright, so in this question, we have to check two things. We have to check and see, one, which point the vector, the position vector is going on to. Am I going to point A or am I going to point B? So let's check the first piece. 3, 4, minus 7. That one is going to A first. 3, 4, minus 7 going to A first. So minus 2, minus 5, and 13 out of the question. 3, 4, 7, minus 7 out of the question. I need to go to a point on the line. So it's either A or B. When I go to a point on the line, I need to now go into a direction on the line. Now going towards B is not going to be 1 minus 1, 6. Going towards B go be the vector AB. So by process of elimination, my answer for 29 is B. Alright, just remember, if you have any questions, feel free to voice them. The general solution for cos 2 theta is equal to cos pi on 3. General solution is going to be 2 theta is going to be 2n pi plus or minus cosine inverse of cosine pi on 3, which is 2n pi plus or minus pi on 3. Divide everything by 2. I'll get n pi plus or minus pi on 6. Answer is C. So again, your skills in doing the product rule and the quotient rule mentally comes into play very heavily in paper 1 and in unit 2. So the derivative is going to be v du dx plus u dv dx. In all of them, they factorized out the x squared. So when I factorize out x squared, I'm going to get 3 sine x plus 3 cos x. It's v dx u. I did that by x cubed. Right? X cubed dv dx. Yeah. Sorry about that. So factor out the x squared, I'm going to get 3 sine x plus x cos x. So x cos x plus 3 sine x is d. Alright, let me loop it all up the place here. 2x minus 1. Actually, I lie there. Hard luck. 10 into minus 1. This could be minus 2 on the denominator here. So you see, again, they put the minus 3 to tidy up. Minus 1 squared minus minus 1 minus 2 over minus 1 minus 1. I'm going to get 1 plus 1 minus 2 over minus 2, and I'm going to get the 0. Right, this is a repeat. I just decided to do it over to show you all, right? Alright, there's a repeat for sure. D was the answer for this. A half x plus a half integral cos x on 2. Aha. Plenty words for a little bit of working, right? A dial on a plane prepares for landing. Preparing for landing registers the number 200 plus 5 sine h on h, where h is the height above the ground. Just as the plane lands, so just as the plane lands, h tends to 0. So I'll get 200 plus 5 sine 0 over 0, and this is my special limit. As h tends to 0, this is going to be 1. So 205 is going to be my answer. Alright, let me check and see if this is indeterminate. 1 take away 4 is 3. Sorry, minus 3. Minus 3 plus 3 is 0. So this is indeed indeterminate. L'Hopital. 2x minus 3 over 2x minus 4. As x tends to 1, I'll get 2 take away 3, which is minus 1. And 2 take away 4, which is minus 2, which is going to give me a half. Ogid. The word is second derivative here, right? So y is equal to 2x plus 1 to the power of a half. When I differentiate, I get y prime 1 half multiplied by 2 multiplied by 2x plus 1 to the power minus a half. So the half of the 2 cancels. So I differentiate again. I will get minus a half into multiplied by 2. Oops. Minus a half multiplied by 2 multiplied by 2x minus 1 to the power minus 3 over 2. So I'm getting a negative, and the only answer that has a negative is A. Alright, and just to do the rest of the working for this, I'll get the minus. I'll get minus 1 over 2x minus 1 to the power of 3 over 2, which is going to be the square root, I'll put it outside here, of 2x minus 1 all cubed, and I can put the cubed on the outside or on the inside. So that's going to be the square root of 2x minus 1 square root 2x minus 1 square root 2x minus 1. This is going to be 2x minus 1 by the square root of 2x minus 1, which further solidifies that A is my answer. Stationary points at x, well, dy dx is going to be 16x plus x to the minus 1, 16 minus 2x to the, 16 take away x to the power minus 2 is equal to 0. So I'm going to get 16 take away 1 over x squared is equal to 0. Rearrange, 16 is 1 over x squared. 1 over 16 is x squared. Plus or minus a quarter is x. So the stationary points at x is equal to plus or minus 1/4. The curve y is equal to 2ax cubed plus 5ax squared plus 20x has a gradient of 0 when x is minus 1. So we're looking at gradient, so we're looking at differentiating this. So dy dx is equal to 3 2s are 6ax squared plus 10ax plus 20. And this has a gradient of 0 when x is 1. So when x is minus 1, dy dx is 0. 0 is equal to 6a into minus 1 squared plus 10a into minus 1 plus 20. 0 is equal to 6a minus 10a plus 20. 6 minus 10 is minus 4a. Move the minus 20. Move the 20 across, and I get a is positive 5. Which of the following real functions has a point of discontinuity? So once we have a denominator that could be equal to 0, then we will have a point of discontinuity, right? U good, these two here is going to be problems, right? So let me check and see which one will give us an answer for that problem. If x squared plus 1 is equal to 0, x is equal to plus or minus the square root of minus 1. So you're not given my answer, so the answer for 39 is A. The point of discontinuity will occur when x is equal to negative 1. Item 40 refers to the following graph not drawn to scale, which shows the regions A and B enclosed by the curve y is equal to x into 4 minus x. The x-axis and the line y, x is equal to 5, The total area of the regions A and B is given by, so we going and be seen modulus down here. So I'm going and know this going to be the modulus, right? It's going to be the modulus between 5 and 4 of the function. Both of them give me the modulus between 5 and 4 of the function. And then I'm going to looking at 4 and 0 of the function. The only difference between C and D is one is a plus and one is a minus. I have to add this area to the modulus of this area to get the total area. Because when I take the modulus of this area, I am getting the positive area. Because the area is located underneath the x-axis, when I integrate properly using my limits, I'm going to get a negative number. That negative number just tells me where the area is, but the number tells me the size of the area. So the modulus will take care of the size of the area, which was negative in the first place, to bring it to be a positive. So the answer for number 40 will be C. This is a repeat question. Let me just make sure 6x was the function to begin with. Where was it? 6x was the function to begin with, so the answer is x cubed plus c. Aha. This is one of the questions that I want all to really etch in all your brains, right? Based on the diagram above, which of the following statements is not correct? So let me check and see which one is correct. F of a is undefined. You are indeed correct. So u is not the answer. The limit as x tends to a of f of x is equal to f of a. Now, if f of a is undefined, this can work. So that is incorrect. All right. Let's check C and D to see if those are correct. So I put in a correct next to it. Correct. The limit as x tends to a of f of x does not exist. This is also correct. That is true. F of x is discontinuous at a. It is discontinuous at a. So this is also correct. So the only incorrect one is B. The displacement s meters of a marble moving along a board at a time t minutes is given by s is equal to this. For what values of t is the displacement of the marble increasing? So for increasing function, the first derivative will be greater than 0. So the s dt is greater than 0. What is the s dt? 12t squared minus 60t plus 72 is greater than 0. I'm looking at greater than 0, so I'm looking at here and here. I'm looking at the union of two separate sets of values. Based on the options, D is my only option. Let me just solve the quadratic and see if we get 2 and 3. BC, alright, good. So this is the quadratic. 12, negative 60, and 72. 3 and 2. So indeed, D is my answer. If h of x is that, then the first derivative equals, so we're going to get 3 multiplied by 4x cubed multiplied by x to the power 4 plus 2 squared. So we're going to get 12x cubed on the outside into x to the power 4 plus 2 squared. So the answer is C. And lastly, when I integrating cosine, when I integrate sine, I get cosine. So when I integrate cosine, I get back sine. So I'm going to get 2 sine 5x. And when I integrating, I have to divide by the differential of the angle. The differential of the angle is 5. Between pi on 2 and 0. So I'll get 2 sine 5 pi on 2 over 5. Take away 2 sine 0 over 5. Sine of 0 is 0. What is sine of 5 pi on 2? Let's check and see. Sine of 5 pi on 2. Oh, I had to put my back in radian measure. Sine of 5 pi on 2 is 1, so my answer is going to be 2/5. And that's it for 2019.